Now, let's begin with part 2 of this series on calculus. We are doing diagnostic test. We answered first 5 questions in part 1. Now, here is question number 6. Write the interval minus 2 to 6 as an absolute function inequality. Now, we are saying that on a real number line, we're looking for x between minus 2 and 6, not including these numbers, right? So we're looking for something which is within this, and this is from minus 2 to 6. So as an inequality, you can always write this as x is greater than minus 2 and is less than 6. Now the question is, write this interval as an absolute function inequality. So that's the question for you. How are you going to do it? Now let's try to understand absolute functions. When we say absolute function, we are interested in finding the mid value, and from there it should be same distance away. So this is the basic concept. So that really helps us to get the answer. So I think you understood the trick involved, right? So what we'll do here is we'll find the midpoint. So first step is find midpoint. So midpoint will be minus 2 plus 6 divided by 2, and that is 4 divided by 2 as 2, right? So we get the center value here, which is at 2, okay, which is at 2. So this is step number 1. Second is, how far are you? So midpoint, find how far are you? How far away, right? That is the second thing. So that is, you can do 6 minus 2 is 4. You could also do minus 2 minus 2 is 4. So both ways, I mean the 4 distance away, of course this is minus 4. However, when we say how far away, we are talking about distance, right? We're talking about distance, which means absolute value, right? Which is always positive. So we normally write this in these terms, absolute value, and absolute value of minus 4 is 4. You get an idea, right? So we are 4 units away from the center 2. Now, will this help you to write down the inequality? Of course. So you move to point 2, that means absolute x minus 2 should be less than 4 units. So that becomes an absolute function as an inequality, which will represent this interval as its solution, right? You get an idea, right? If you solve this inequality, you get that as your solution. So this is how you can represent intervals in terms of absolute function inequality. Good concept to know as you move on to calculus. Now question number 7 here is to expand 2a minus 1 to the power of 5. Well, to expand this, I hope you remember Pascal's triangle. So you may need Pascal's triangle to expand such binomial expressions. So let me make one here. Let's say we begin from number 1 and we just move diagonally, right? Does that remind you of anything? Okay, so, and then we go like this. We add the previous 2. 1 plus 1 is 2. And then we further continue. So we get 1. 1 plus 2 is 3. 3. It is symmetric. You can see that, right? So it's easy to add numbers. Do half of them. 1 and 1 always on the sides, correct? So when you add them, you get 4 and 6, 6 and then 4, correct? Now this is the 4th row. Then again we move on. Since we are interested in to the power of 5, we have to do 5 rows. This is 0th row. Is it okay? Then we can 1st, 2nd, 3rd, 4th, and now we are on the 5th row. So we get 4 plus 1 is 5, 4 plus 6 is 10, 10, 4 plus 1 is 5, and 1. So these are the coefficients when you expand this. And remember, whenever you expand a binomial expression, when you add their powers will always be same, 5, correct? So now it is easy. So we can now expand this, which is 2a minus 1 to the power of 5 as equal to. So the first term is 2a. So we have 2a to the power of 5 times minus 1 to the power of 0. Do you see that? So that is how you put the expressions together. Then let me write plus. Now this power will decrease by 1. And here we had the coefficient 1. Let me write 1 here. And then the coefficient 5. We write 5 here. Okay. And the first term, which is 2a, decrease the power by 1 and increase this power by 1. So when you add them up, still it is 5. Perfect. Now plus. Next is 10. So that becomes the coefficient of these terms. So I hope that's a good revision of Pascal's triangle application. You could always use the binomial theorem also, right? Minus 1 square. So 3 plus 2 is 5. Now let me add here. So we have plus. Next is again 10. And then we have 2a to the power of 2 minus 1 cube, right? And then 5. 2a to the power of 1 and minus 1 to the power of 4. Normally you should not be writing 1. It is well understood, right? Plus the last term here, which is 2a to the power of 0 and minus 1 to the power of 5. So, and normally you should not write 1 also. But I'm writing all this just to show you how it links with our fifth row, right? This is our fifth row. So fifth row gives you coefficients, right? Now we can rewrite. So 2a to the power of 5 minus 1, anything to the power of 0 is 1. 2 to the power of 5 is 32. So we can write this as 32a to the power of 5, correct? Now next term is 5 times, let me write 5 times 2 to the power of 4 is 16, right? So we get 16a to the power of 4, and this is minus 1, plus 10 times 2 to the power of 3 is 8, right? So 8a cube, and that is just 1. So I'm just leaving it away, even powers, right? Then we have plus 10 times 2 square is 4, so 4a square, and this is minus 1, right? Okay, so alternate terms are negative. That's why I'm keeping them. So 5 times 2 is 10. Let me write this as 10a, but this is positive. And the last term here will again be negative term. Anything to the power of 0 is 1, so I do get negative 1, right? So now let me rewrite the final answer. So we have 32a to the power of 5, and we can multiply these two with a negative sign this time, minus. So 5 times 6 is 30, and 5 times 1 and 3, 8. You'll notice that till now we have done all the examples without calculator. So in diagnostic test, calculator may not be allowed. So selection of my questions are such that you could do without calculator, right? I forgot to tell you that earlier. So now we have 10 times 8, which is 80 a cube. And then we have a negative sign. 4 times 10 is 40. Oh, 80. 8 times 10. Minus 40 a square. And then we have the last term, which is minus 10a, right? Let me rewrite this. So we have 32a to the power of 5 minus 80a to the power of 4 plus 80a cube minus 40a square minus 10a, right? So that's what you get as the expansion of 2a minus 1 to the power of 5. Okay. So I hope you recall the Pascal's triangle and understand how we could answer such questions, right? Okay, now let's take up question number 8, which is determine inverse of the function y equals to x squared minus 2x plus 3, satisfying that f inverse of 6 is minus 1. Okay, so that should not be very difficult. However, there's a trick involved. So we have to find inverse function, right? So we need to find inverse of y equals to x squared minus 2x plus 3. And we are also given that f inverse of 6 is minus 1. Now how does that help? As you know, inverse of a quadratic function is not a function. So if you do some restrictions, it becomes a function. So basically, this is a restriction which will help you to decide plus or minus sign at the end. Okay. Now let's see how to find inverse of this function. Now whenever a quadratic function is given to you, to find inverse, we need to complete squares. Okay. Only then you can find inverse. So first part we'll do complete the squares, and then we'll follow the steps to find inverse. So we have y equals to x squared minus 2x plus 3. To complete the squares, well, there's no coefficient. 1 is the coefficient, so the steps are simpler. So we get x squared minus 2x, half of 2 is 1, so we'll add 1 square and subtract 1 square. Is it okay? Now, first 3 terms make a perfect square. In this case, it is x minus 1 whole square, and we have minus 1 plus 3. And that gives us x minus 1 whole square plus 2. So that becomes the required function. Now, to find inverse, what are we going to do? We need to swap x and y, correct? And then solve for y. So that's what we are going to do now. Let's do it here. So when you swap x and y, you get x as equals to y minus 1 whole square plus 2. Bringing 2 to the left side gives us x minus 2 equals to y minus 1 whole square. Now square root it. So square root x minus 2. You get plus and minus y minus 1. Bring 1 this side. 1 plus minus square root x minus 2 equals to y. Now at this stage, you have to look into the given condition. That is to say, this inverse should satisfy the condition that if x value is 6, y should be minus 1. So what will work for that? Plus sign or minus sign? Correct? So if I write 6 here, so let's test. So we are doing the test for x equals to 6. In this particular expression, what do we get? 1 plus minus square root of 6 minus 2. And that gives you 1 plus minus square root of 4, which is 1 plus minus 2. Now out of these, we get actually 2 values. One should be 3, the other one is minus 1. Since we are interested in minus 1, we will choose negative sign. Is it okay? So since the point 6 minus 1 is on inverse, we'll use f inverse x as equal to 1 minus square root of x minus 2. Do you get an idea? So that becomes our answer. So it is not plus minus. Plus minus means it is not a function. We have got 2 values. The question specified 1, that f inverse of 6 is minus 1. So we'll select the domain of the function on the negative side. So that is your function. Is it okay? Now, as a question for you, you should write domain and range for f inverse. I should have written for f inverse x. Okay. So as an additional question, you can take up the same inverse function and write down domain range of the inverse function. Now let's continue with part 2, diagnostic. And if you have come so far, let me share with you that in this series, what am I going to discuss? So we'll do all these 15 topics. So we are beginning with diagnostic. We'll go to rate of change, limits, derivatives, implicit differentiation, applications based on velocity, acceleration, related rates, extreme values, curve sketching, trigonometric functions, exponential logarithmic functions, antiderivatives, area under curve, basics about integrals, and we'll also take up questions based on IB, AP, AB calculus, and IIT JEE entrance examination, that is, test questions. So that will really help you all to understand this topic or all the topics in calculus fairly well. So let's begin with answering question number 9, which is write the domain range of y equals to minus 3 square root of 16 minus x square. So what is this type of function? What does it represent? Well, if you need to sketch it, it will look like a semicircle. Minus means all values are negative. So it is going to look like this. Perfect. Now, when we talk about domain and range, let's look into the function in details. It is minus 3 square root of 16 minus x square. All this you're supposed to know, right? Now, the idea is that within the square root, we should always have non-negative number. That is to say, 16 minus x square should always be greater than equal to 0. Correct? Now, that is to say that if this is greater than equal to 0, what is x? Well, you could say that x square, you can take it to the other side, is less than equal to 16. Perfect. Or x is between these two values, which are between minus 4 and plus 4. Right? Now, when you do square root, the idea is when you do square root, important thing here is to understand. Let me do one more step here. So at this stage, what are we doing? We are doing square root of a function. So you should know square root of x square actually is absolute value of x. And that is why we are saying that x should be between minus 4 to plus 4. The other way to look into it is that you could actually sketch this function, right? And then figure out which is a portion which is greater than 0. Correct? So the alternate way look into this is like this. You could sketch this particular function, which is 16 minus x squared, correct? So if you sketch 16 minus x squared, what do you get? We're just sketching 16 minus x squared, nothing else, okay? That is to say, the function will be, you have to go 16 up and open downwards, correct? Like this. At x equals to 0, the value is, if I write x equals to 0, what you get here is 16, correct? Now, and the two zeros are at minus 4 and plus 4. So this interval between minus 4 and plus 4 is when the function is positive. Correct? So that becomes the domain of the function. So all this we did to check domain. What values can x take? Now, if you sketch this function, which is, let me say y here, x here, this value is minus 4, this is plus 4, and y is equal to this function. Because of minus 3, it like moves downwards. Now if x is 0, what is the value of this function? If I write x equals to 0, I get y equals to minus 3 square root of 16 minus 0, which is minus 3 times 4 or minus 12. Okay, minus 12 or equals to minus 12. That means this value is minus 12. Now with all that information, you can always write domain and range. So let me write down the answer. Domain of this particular function is x belongs to real numbers. where x is greater than equal to minus 4 and less than equals to plus 4. Correct? As far as the range is concerned, range is y belongs to real numbers, where y is between 0 and minus 12. So y is greater than equals to minus 12 and less than equals to 0. So that is how you can get domain and range of such functions. So as a part of diagnostic, you should actually look into many other examples with combination of functions as we have taken up here. Now let's look into question number 10, which is based on piecewise function. The equation here is find a and b such that the function is continuous. You can always pause the video, answer the question, and then look into my suggestions. Now if you check the function, we know minus x is continuous. This is a parabola which is also continuous. This is constant 6. It is also continuous. Now when we say this function is continuous, that means we should check at these boundaries, right? At minus 2 there is a possibility of discontinuity, and even at 0 there is a possibility of discontinuity. To make the function continuous, we should check at minus 2 and at 0, right? So what happens when x is equals to minus 2? And what happens when x is equal to 0? So those are two very critical values. So these 2 points, these are 3 different pieces. Function is continuous when they overlap, correct? So when f of x, if we substitute x as minus 2, what do we get? So we could get from the first leg, which is this one, we are saying that its value should be x is minus 2. So we'll write x as minus 2 here. We get minus 2. Is it okay? And from this portion, when it is greater than minus 2, it should start from the same place, right? So if I substitute minus 2 here, I get a times minus 2 squared plus b. Now that gives me an equation. 2 equals to 4a plus b, right? On the other hand, if I substitute 0, now 0 links these 2 pieces. They should overlap, right? So if I substitute 0 here, I get, so we are substituting 0. We get b here. And if I substitute 0 here, well, it is constant 6. B should be equal to 6. So from the second condition, it is clear that b is 6. So if I substitute b equals to 6 here, I can find the value of a, right? So substituting b equals to 6, we get, let's do it this side. Substituting b equals to 6 here, we get 2 equals to 4a plus 6, and then we can arrange. 2 minus 6 is 4a, or this is minus 4 divided by 4 is a, so the value of a is minus 1, correct? So for continuous function, we get our answer that a should be equal to minus 1 and b should be equal to 6. Only then this piecewise function will be continuous. Otherwise, it will not be continuous, right? So I hope with this you understand piecewise functions and the rule for continuity. So the idea is these 2 pieces should overlap and these 2 pieces should also overlap. Let's take one more question to end up part 2. And this question is, identify the intervals of increase and decrease, symmetry, asymptotes, and behavior, and domain and range of the function given to us. So in part 2, we are discussing mainly functions. Okay, so let's rewrite the function, which is g of x equals to x cubed over x squared plus 1 whole square. Now, I hope you remember the strategies which you've learned to sketch a rational function. So those will help you here. So I'll not get into great details. You may have to review those things, right? So when you're taking calculus, you should know all of them. But anyway, let me give you key features here. So first, let's look into zeros. So what we see here is that we have a 0 at, we have to say x cube equals to 0. That means x equals to 0. So we have a 0 here, correct? Then we can look into vertical asymptotes. So vertical asymptotes in this case is when denominator is 0. That is x squared minus 1 equals to 0. And that gives you x is equals to plus minus 1. For both these values, it will be 0. So let me just sketch vertical asymptotes here. For greater details, you can always look into my videos on sketching rational functions. Okay, now we can look into horizontal asymptote. Since the degree of denominator is 4, 2 times 2, perfect. So you add them up, 2 plus 2, as I should say. And numerator is 3, that means degree of denominator is higher. So we have a horizontal asymptote at y equals to 0. So that is your horizontal asymptote. So let me just show it here in a dotted line. So we are more worried about the extremes. Now, with that and some more information, you can always sketch this particular curve, right? So to make things simple, what I will do is I'll take some value. So let us take value of function at on the left side of minus 1. So let's say minus 2. Minus 2, okay. So what we get here is in the numerator we get minus 8, and in the denominator minus 2 becomes square, so 4 minus 1. It is always positive. Do you see that? Denominator is always positive, so numerator decides the sign. So when you are on this side negative, you will get negative portion, and you know this is a vertical asymptote. So without doing many calculations, I will just sketch it. So what we get here is a function which is kind of like this. Similarly, I could say, well, on the positive side, it should be like this. So I'm not really getting into details, but kind of giving you hints to sketch. This is cubic 0, right? So that means it should be kind of like this. And let me just go with the asymptotes. So this is the expected function. Now this is a very important function. You will also see that the graph of the function crosses horizontal asymptote. Do you see that? Some students think that asymptotes cannot be crossed. Vertical asymptote you cannot cross. That is a restricting domain. However, you can always cross horizontal asymptote. Anyway, let's write down answers for these. So take your time to answer all these. Intervals of increasing and decreasing, symmetry, asymptotes and behavior, and domain range of this particular function. Now let me answer symmetry first for you. So when we are talking about symmetry, we really want to figure out what is g of minus x. So if I write minus x here, I get minus x whole cube over minus x whole square minus 1. Everything is squared. And this gives me minus x cube. And the denominator is exactly as it was before. But it is negative of our function. So we could write this as minus g of x. That means what? This means odd symmetry, right? Now you can see from the graph that it is symmetric about origin. So it does have odd symmetry. Okay. Now let's write down answers for all these parts. So let's say increase. When is it increasing? It is increasing in between, right? So between minus 1 to plus 1. Decrease. When is it decreasing? From minus infinity to minus 1 and from 1 to infinity, correct? Symmetry, odd symmetry. That is how you prove it, right? Since g of minus x is minus of gx. Asymptotes, we have already written. End behavior. So end behavior means when x approaches minus infinity, y approaches what? It approaches 0, but from the negative side. And when x approaches positive infinity, y again approaches 0, but this time from positive side. So that's the end behavior. Domain and range. Okay, so domain is x belongs to real numbers. However, restriction is that x is not equal to plus minus 1, and range is y belongs to real numbers. Is there any restriction? Well, the graph crosses the origin, that is the x-axis. So all values, is that okay? So that's the range for the given function. So I hope with this example you have understood a greater part of functions in part 2. And I hope this series is helping you to recall what you learned so far and how useful it will be in doing calculus. So again, I'm just reminding you that you can register free and just share with me your email IDs and your views, and feel free to post questions. Thanks for watching and all the best. We'll now take up part 3, in which we'll discuss rate of change. Thank you and all the best.